Assalamualaikum and hi. This presentation is for subject dynamics and mechanics of machine. Subject code is BMMM 2313. As you can see, there are student names, also metric number. There are 5 of us. We will present our project about projectile motion. Okay, we will go to the introduction first. Projectile motion is a form of motion experienced by an object or particles that is projected near Earth's ground and move along a curved path under the action of gravity only. As we are assigned to make a project based on projectile motion, and we are able to build a prototype. The launcher consists of an arm with a bowl-shaped bucket attached to the end, and when the arm rotates at a high speed and throw the payload out of the bucket to the target. This crossbar is positioned so as to stop the arm at the desired angle. The physics behind the launcher is basically the use of an energy storage mechanism to rotate the arm. Okay, these are some pictures of our prototype. As you can see, this prototype made by some material such as rubber band, woods, and plastic cup.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zulhairi bin Abdul Aziz. So next is a calculation. The first step to do a calculation is to draw the diagram of the project. So this is our diagram of the project. We have 85 degrees. Height we have 6.1 cm and the distance we have 1.5 meter. So next we have to use this formula to find the velocity and time of flight. So based on this formula, we can find the x and y motion. For the x motion, we have initial distance SO equal to 0 meter. The final distance S is 1.5 meter and the initial velocity Vx, we have VO cos 85 degrees. So S equal to SO plus VOT. So S, we have 1.5 meter, SO 0 meter, plus BO cos 85 degrees times with T. So we got a first equation, T equal to 1.5 divided by BO cos 85 degrees. So for the Y motion, we have initial height SO equal to 0 meter, the final height S equal to 0 meter, and the initial velocity Vy, we have VO sin 85 degrees. So S equal to SO plus BOT plus 1 over 2 times ACT square. So S is 0, SO also 0 plus BO sin 85 degrees times T minus 1 over 2 times 9.81 times T square. So we got a second equation, 4.905 T square equal to 0 plus BO sin 85 degrees times T. So we got a first equation and second equation here. So we can substitute equation 1 into equation 2. So we got a 4.095 times 1.5 divided by BO cos 85 degrees square equal to BO sin 85 degrees times with 1.5 divided by BO cos 85 degrees. So we got a equation BO square times cos 85 square equal to 4.905 times 1.5 square divided by 1.5 tan 85 degrees. From this equation, we can find initial velocity VO and time of flight T. So we got initial velocity VO equal to 9.205 meter per second, and time of flight T we got 1.87 second.
Hello and hi everyone. My name is Wan Abdurrahman. And today I would like to present about conservation of energy. So the formula given is K1 plus U1 equal to K2 plus U2. So the K1 is initial kinetic energy, U1 initial potential energy, K2 final kinetic energy, and U2 is final potential energy. To cancel out the energy that is not used in this formula, we have to take a look at the video of the launcher. The video shows that the launcher shoots the ping pong ball to the air, and that represents the U1 potential energy that produced by the launcher. So we can cancel out K1 as there is no initial kinetic energy. Q1 we can derive it to a different formula of energy. And the second formula is U equal 1 over 2 K delta X power of 2. U means elastic energy, so the K is spring constant. Delta X is change in position. But before using the formula, we have to make another experiment on the rubber band that used in the launcher, which is the same concept as a spring to find the elongation of rubber. So we have to make a table. So the table we must divide into 3 columns. That means we have mass, force, and delta X change in position. Then we must put the mass from starting from the 0 until 0.5. That means every single row we add 0.1 kilogram. After we get the mass, we must time the gravity which is 9.81. So the mass times the gravity, we get the force. After we get the force, we get the value of the change in position. After complete this table, we get the mass of the ping pong is 2.7 gram and the rubber band length is 0.7 meter and the K constant is 50.42. Thank you.
Selamat sejahtera. My name is Johan. Now I would like to talk about my part, which is this graph. This is a force versus delta X graph. So here, as we can see, as the force increases, delta X increases. So there was 5 attempts, and as the force increases, delta X increases. On the graph is shown that the K equals to spring constant that produced and made by a different experiment to calculate the elastics of the rubber band, which is the same principle as a spring. But before calculating it, first step we have to do is to complete out energy formula, which can be determined in the video. In the video shown after the ping pong launcher shot the ping pong ball, the ping pong launcher change energy from potential energy to kinetic energy. So here we can cancel out U2 because there is no potential energy shown after the ping pong ball was shot. It is because the ping pong ball's energy became kinetic energy, which we use the kinetic energy formula as shown below. Here, as we can see,
upon cancelling out K1 and U2, which are equal to 0, the formula will become as shown below. U1 equals to K2 And we can combine all the formula of elastic energy and kinetic energy to become as half k delta x square equals to half mv square. By using the formula, we can add up the data that we have collected, which is mass of 2.7 gram, the rubber length of 0.07 meter, k constant with a 50.42 and velocity of 9.205 meter per second. We're going to be using the half k delta x square equals to half mv square formula. First, we put in all our data into the formula, half with a k constant of 50.42 multiplied with delta x square equals to half times the mass of the ping pong, which is 0.0027, and the velocity of 9.205 squared. Hence, we'll get the value of 25.21 multiplied by delta x square equaling to 0.11438. To find the delta x square, we need to divide 0.11438 with 25.21 and finally square root the answer to get delta x equals to 0.067 meter. This is the video for our project presenting the ping pong launcher. That is a precise shot, and that's all from us. Thank you.